Okay, I'm going to do a quick overview over the animal metabolism lab. So if you haven't unlocked the lab, be sure to do the pre-lab questions. But what we're looking for is going through these challenges and relating all of these values. So respiratory quotient, RIR, basal metabolic rate, and Q10, and different types of hypotheses that are happening. We are not doing this butter within our actual experiments, but these are where you can think what will happen to the metabolic rate. So these are the values that we're going to be pulling out of this. We're going to be looking at stress, syrup, and temperature. The Power Lab setup actually includes a video on what's actually being performed. All this wasn't available because whenever we actually work with these computers, we didn't have the update for this, but you can see how it's going to set up the Power Labs. This metabolic cage is another one of the setups, but it's literally just attaching a temperature probe, and then you have these thermistor and spirometer pods, which are also connected up with your Power Lab. This procedure you don't need to do because we're not zeroing anything. You don't have to do a level check. This is where we're actually performing the experiment. And how you actually do this is that you're going to hold down the shift button, click on start, and then enter the access code to use example data. It's going to be BIOL, all caps, 4510. Once you add that, I'll try to save that, and then you can see that we have these labels here. So this is the stress-free baseline. And you can see that it's staying pretty average on here. And I can actually adjust the scales on here so we can actually see everything. And it's gonna go over, this is the start of the stressful stimuli. You can see temperature is changing. So they're actually exposing it to light and sound. And then they open up the lid. So this is actually not very useful data. Well, actually opened up in this area, and then they added it back in. So whenever you're selecting these, you'd be looking at it here, or you'd be looking at it in this area. You can see how oxygen percent and CO2 percent are paired together. I discussed that in class just today. And then the end of the stressful stimuli. So this would be one procedure. You would collect that data, and then for analysis, you can, so for instance, for no stress, you drag to select, but you don't want to drag past these gaps in data. And so RER, you can drag those values in VO2, and then be sure to include the weight of your cricket. That is important. There it is. So the weight of your cricket on these is going to be 1 gram. Actually, I should tell you its weight. It should be like 1.4 grams, something like that. No, it's 2.43 grams. Under 2.43 grams, and you will collect your metabolic rate under no stress, and then under high stress conditions. You can see the lid. This area is, actually, let me check these, yeah. You want to avoid those larger areas though, those large gaps. Then you would drag those values through and get your metabolic rate for the other ones. And you can answer questions relating to those. And then you're performing the same idea here, where you type in BIOL 3510, and you can see which experiments we're performing on. So this one has its own insect weight of 0.52 grams, and it was fed butter. And you can see this characteristic curve of CO2 release after 5 minutes, where it's really high, and then it starts going back down. I enable this, you should be able to see it better. So over time, the metabolic rate spikes up and then it goes back down. Now the weird thing with this data is that it actually goes below baseline. So, and we do not use butter in our actual experiments. So as you're going through on these, just note that we're using sugar. The sugar data is what's going to be in our actual results, because the RER is at a value of 0.85 rather than 1.0. And so that's based off of this relationship for oxygen consumed and CO2 released. Butter is going to have one near 0.75, where sugar is going to have it near 1, and then proteins are going to have it near 0.65. And then you would answer these questions for understanding. And again, you would go through temperature, answer the questions, and then distinguish between RAR and RQ. It's talking about between the cellular level and between the animal level. So RQ is actually the quotient of the fuel source itself. And then why would you control by weight, time, and the milliliters of oxygen? There's pretty obvious reasons why, and talk about the variability in standard metabolic rates, but there isn't a syrup data set in here. It's butter, unfortunately. Yeah, and then you would view, you don't have to submit it. This is how you can go through and understand what sorts of effects are happening. So we have 3 main effects here: stress, food type, and temperature. So